Right. 2.16 is a purely mathematical problem, and I really don't like those because they tend to be sort of the biggest pains to actually work through. Regardless, it is good practice, and it does sort of get us more comfortable with the Hermite polynomials, which become very important sort of later down the line. So we might as well just grit our teeth and go through with this. So starting with part A, we're given the Rodriguez formula, which tells us how to find arbitrary values of n for Hermite polynomials, and we're asked to use it to derive h3 and h4. So just so we can check our work, we're going to use it on h3 and h4. Starting with h3. So h3 for n equals 3 is going to equal negative 1 to the power of 3 times e to the y squared times d by dy third derivative times e to the negative y squared. Working this out, we get negative e to the y squared, and then d by dy 2 of negative 2y e to the negative y squared. We're going to multiply this out, move the 2 out of the way, so this is going to give us 2e to the y squared times d by dy squared of y e to the negative y squared, which equals 2e to the y squared d by dy, this time just once, and then using product rule, or chain rule, whichever one, I forgot what it's called, e to the negative y squared minus 2y squared e to the negative y squared. Is that correct? Negative 2y, so negative 2y squared e to the negative y squared, yes. Then 2e to the y squared, and then finally negative 2e to the negative y squared, or negative 2y e to the negative y squared. Let's see, subtracted by, and then we'll use another chain rule on this. This gives us 4y times e to the negative y squared, and then minus 4y cubed e to the negative y squared. Is that correct? Yes, it is. And then moving this down, this is going to give us 2e to the y squared times negative 2y e to the negative y squared minus 4y e to the negative y squared plus 4y cubed e to the negative y squared. And from this point, we can factor out the e's. So this cancels with all of the exponentials. And what we're left with is 2 multiplied by negative 2y minus 4y, so that's negative 6y plus 4y cubed. Multiply the 2 over, what we're left with is 8y cubed minus 12y. And just to double check, 8y cubed minus 12y. And so that's h3. Okay, now let's do the same thing with h4. So h4, whoops, forgot to switch the brush. h4 is going to equal negative 1 to the power of 4th times e to the y squared d by dy to the power of 4 times e to the negative y squared. Immediately, the 1's all cancel to positive 1, so that we're left with e to the y squared times d by dy cubed times negative 2y times e to the negative y squared. We move the negative 2 out, we're left with negative 2 e to the y squared d by dy cubed of y times e to the negative y squared. Then we use product rule. This gives us negative 2e to the y squared times d by dy squared times e to the negative y squared minus 2y squared e to the negative y squared, because that brings out a negative 2y. Yeah. Okay, do it again. Negative 2e to the y squared d by dy of negative 2y e to the negative y squared minus, and then using a second set of product rules, this is going to give us 4y e to the negative y squared minus 4y cubed e to the negative y squared. And we combine terms and all that stuff, so this is going to give us negative 2e to the y squared d by dy, and then what is this? Let's see, negative 6y e to the negative y squared plus 4y cubed e to the negative y squared. Then we derive this one final time, and this is going to give us negative 2 e to the y squared multiplied by product rule twice, so negative 6e to the negative y squared plus 12y squared e to the negative y squared, because that brings down to negative 2, and then plus 12y squared e to the negative y squared minus 8y fourth e to the negative y squared. Combine all the e to the y terms, we have negative 2 times negative 6 plus 24y squared, because combining these two terms, and then minus 8y to the fourth. So this gives us 16y to the fourth minus 48y squared plus 12. And just to make sure that's correct, 16y to the fourth, negative 48y squared, and then 12. And we are done with part A. Part B, we're basically doing the same thing, but we're using a recursive formula this time. So let's, we're trying to find h5 and h6. So let's start with just n equals 4, which gives h5. So in n equals 4 case, we have h of 4 plus 1 is equal to 2 times y times h of 4 minus 2 times 4 multiplied by h of 4 minus 1. And from previously, we have in part A that we know that h3 is equal to 8y cubed minus 12y, and we also know that h4 is equal to, let me just pull that up real quick, 16y4 minus 48y squared plus 12. So if we plug all these in, what we get is that h5 is equal to 2y times h4, 16y to the fourth minus 48y squared plus 12 minus 8 times h3, which is 8y cubed minus 12y. This is going to give us, let's see, 32y to the fifth minus, that's 896y cubed plus 24 times y. Minus 64y cubed plus 8 times 2 is 16, 96y. Then we just combine like terms, and what we're left with is 32y to the fifth, and then, let's see, we have 2y cubed, so minus 10, 160y cubed, plus, that's 10, and 120y. And just to verify that, our h5 here is indeed 32y to the fifth minus 160y cubed plus 120y. Next off, n equals 5. This is going to give us h of 5 plus 1 is equal to 2 times, let's see, what was it? Yeah, 2 times y. Here, let me just pull it like this to make this a little bit nicer. 2 times y multiplied by h of 5 minus 2 times 5 times h5 minus 1. So what's this going to give us? We're going to be left with h6 is equal to 2y h5 minus 10 times h4. We have h5 and h4, so h6 is going to equal 2y times h5, which we solved as 32y to the fifth minus 160y cubed plus 120y, and then subtracted by 10 times the fourth Hermite, which we have all the way up here. So this is going to give us 16y to the fourth minus 48y squared plus 12. Then from there, we just solve this. So this is going to give us, let's see, 6y to the sixth minus 0, 6 times 2 is 12, to 320y to the fourth plus 240y squared minus 160y to the fourth plus 480y squared minus 120. Then we combine like terms. This is going to give us 64y to the sixth at the front. Let's see, we have 2y to the fourth powers. We combine those. This is going to give us 0, 8, 480y to the fourth. 6, 7, 8, 3, 4, yeah. And then we have two y squared terms. This is going to add to give us 0, 8 plus 4 is 12, 4, 5, 6, 720y squared. And then finally minus 120, and this is h6. In part C, we have a way of deriving sort of the Hermite polynomials without knowing the actual form of the Hermite polynomial itself by using the previous one in sort of the list. We're asked to verify this by differentiating h5 and h6. So we have h5 and h6 here. Let's start by manually differentiating these without using this formula. So dh5 by dy is going to give us, let's see, 10. 2 times 5 is 10, 15, 60, 160 y to the fourth, minus 0, 6 times 3 is 18, 480 y squared, plus 120. And dh6 with respect to y is going to give us 4 times 6 is 24, 36, 384 y to the fifth. Is that correct? 24, 36, 37, yeah. Minus 0, 4 times 8 is 32, 16, 17, 18, 19, 19, 20 times y to the third, plus 0 for 14, 14, 40 y, and then the 120 is just nothing. Okay, so these are the manual derivatives. Let's check this by using this recursive formula. So we have dh5 by dy is apparently equal to 2 times n, which is 5, times h of 5 minus 1, which is 4. We know h4 from right here, sort of. So if we plug this in, this is going to give us 10 times h4, which is 16 y to the fourth, minus 48 y squared, plus 12. So this is going to give us 160 y to the fourth, minus 480 y squared, plus 120. And if we look, this is indeed match what we got right here. Next, doing the same thing for h6, we have dh6 with respect to y is going to equal 2 times n, which in this case is 6, multiplied by h of 6 minus 1, which is 5. This is going to give us 12 times h5, which is 32 y to the fifth, minus 160 times y cubed, plus 120 times y. And this is, let's see, I'm too lazy to do the math for 12 times 32, so I'm just going to plug this into my calculator. 384 times y to the fifth minus 160 times 12. I believe that's, yeah, that is also 1920. Y cubed plus 12 times 120, that is 1440. Times y, and if we compare this, this does indeed match what we got up here, and thus we are done with part C. Now we have part D, which is probably the most painful one on this list. We're given a generating function, f equals e to the power of negative z squared plus 2z times y, and we're told that the nth Hermite polynomial is equivalent to the nth derivative of this term. So our job is then to derive this 1, 2, and then 3 times respectively in order to find the corresponding Hermite polynomial by plugging in z is equal to 0. So let's do that, starting with h1. So df by dz, which is the first z derivative of this, is going to give us, let's see, negative 2z plus 2y times e to the power of negative z squared plus 2zy. Then h1 is going to be df by dz evaluated at z equals 0, which is going to give us 2y times e to the power of 0, which is just 2y. And that is indeed what we have for h1. Next, we take the second derivative of this, so d2f by dz squared is going to equal, and we have to use product rule here, so let's see, box prime times triangle, so this is going to give us negative 2 times e to the power of negative z squared plus 2zy, and then plus triangle prime times box, so plus, and then negative 2z plus 2y times negative 2z plus 2y times e to the power of negative z squared plus 2zy. And this is going to give us negative 2 e to the power of negative z squared plus 2zy multiplied, or plus, and then negative 2z plus 2y squared times e to the negative z squared plus 2zy. And then h2 is going to be this with z evaluated at 0. So this is going to equal negative 2 times e to the 0, which is just 1. And then plus, and let's see, we have 2y squared times e to the 0. So this is just 4y squared minus 2, and that does indeed match h2 right here. Next, we take the third derivative of this. So this is the painful one, d3f by dz cubed. This is going to give us, let's see, negative 2 multiplied by negative 2z plus 2y times e to the power of negative z squared plus 2zy. And then we have this horrible product rule thing that we have to do. So let's see. We have the derivative of this first multiplied by the exponential. So this is going to give us 2 times negative 2z plus 2y multiplied by the derivative of this inner term, which is going to be negative 2 because we're using chain rule multiple times here. And then we're multiplying by e to the power of negative z squared plus 2zy. So that's box prime times triangle, and we're adding triangle prime times box. So plus, and then negative 2z plus 2y multiplied by negative 2z plus 2y squared, which is going to give us this cube times e to the power of negative z squared plus 2zy. And then h3 is going to be this evaluated at z equals to 0. So this is going to give us negative 2 times 2y, and then this exponential, which doesn't matter, added with, and let's see, 2 times 2y times negative 2, and then e to the 0, which is just 1, and then plus 2y cubed, and then the exponential goes to nothing, so this is going to give us negative 4y, and then minus 8y, plus 8y cubed, or 8y cubed minus 12y. If we look up, we do indeed have 8y cubed minus 12y. And with that, we are done with this mathematical exercise.